Namaste. Welcome to the today's virtual class. Subject Science and Technology Grade 10, Unit 14, Classification of Elements. Dear students, we are in third part of this unit. What did we discuss in previous lesson? Do you remember? Yes. In previous classes, we discussed about the history of classification of elements. Elements are classified according to chemical and physical properties, according to similarities and dissimilarities. Isn't it? Many attempts were performed by the different scientists in different time. And we have discussed about the features of the Mendeleev's periodic table, Mendeleev's periodic law, modern periodic law and modern periodic table. Yes, Mendeleev periodic table was based on increasing order of atomic weight. That means elements are arranged in increasing order of atomic weight. But in modern periodic table, elements are arranged in increasing order of atomic number, so that different characteristics were analyzed scientifically, and some of the defects, demerits of Mendeleev's periodic table were also addressed in the modern periodic table. Yes, and we have discussed about the features, characteristics of modern periodic table also. Remember, there are how many groups in modern periodic table? Yes, there are altogether how many groups? 18 groups. Dear students, modern periodic table has 18 groups and 7 periods, isn't it? This modern periodic table is more scientific and solve the difficulties, demerits shown by the Mendeleev's periodic table. Yes, and today we are going to discuss about what are the different type of elements placed in the modern periodic table. Remember, what kind of elements are there which are classified according to physical and chemical properties? Yes, definitely. There are metals, some elements are non-metals, some elements are metalloids, some are transition elements, and so on. Yes, we are going to discuss about these varieties of elements which are placed in the modern periodic table with their features, characteristics. Let's discuss about the process of classification and that electronic configuration which we have discussed in the previous lesson. I am going to demonstrate you one model of electronic configuration which is based on the subcell electronic configuration. Dear students, let's prepare electronic configuration of sulfur. Sulfur, what is atomic number? Let's write electronic configuration of sulfur. Its atomic number is, yes, its atomic number is 16. First cell K, second cell L, and third cell M. Dear students, according to 2n square rule, we can fill 2 electron in K, and what is the capacity of L? Yes, 8 electron. In M, remaining how many electrons are left? 8 plus 2, 10. Now remaining electrons are 6. 6 electrons are filled in M. Students, it is the configuration according to 2n square rule, cell or energy level configuration. But remember, inside K there is 1s subcell, isn't it? 1s, 2. In L cell there is 2s and 2p. Remember, what is the capacity of electron? Yes, S carry 2 electron and P carries 6 electron, which we have already discussed in the previous class. So 6 plus 2 altogether 8 electrons. Now remember, in M cell there is 3s, 3p and 3d also. But how many electrons are left? Yes, 2 electrons are filled in S, then remaining electron will be, look at here, 8 plus 2, 10, 10 plus 2, 12 electron. How many electrons are there? Now 4 electron. Yes. Now electron are finished, 16 electron are finished, then we don't need 3D subcell. So its subcell electronic configuration is 1s2, 2s2, 2p6, 3s2 and 3p4. According to this electronic configuration, we have learned to determine the group, period and block also. Remember, its group is, try to find what is its group. Sure, yes, look at here, there are 6 electrons in the valence shell, so it is in group 6, group 6A, BIA, or in number it is group 16. Then its period is, what is its period? Sure, yes, period 3, because how many cells are there? K, L, M, 3 cells are there, so period 3. And its block is, what is its block? Yes, subcell, last subcell, valence subcell gives the block, that is P block, which we have practiced in the previous class. And what is its valency? Remember, yes, valence shell has 6 electrons, so it gives the valency 2, isn't it? So will it be positive or negative? Yes, it gains 2 electrons. It is negative charge. It is negative charge element, negative charge radical. So this is the electronic configuration according to cell and subcell. Now let's revise it, dear students. See here, cell are K, L, M, N, O, P, Q. How many cells? There are 7 cells. So the cells are represented by the particular number, that is n equal to 1, n equal to 2, n equal to 3, n equal to 4 and so on for the cell. And within the cell, look at here, subcell. In K there is 1s subcell, 1 represents the cell number, that is n, value of n, principal quantum number, that is n equal to 1. And L cell contains 2s and 2p. These are subcell. And remember, M has 3s, 3p, 3d. Similarly, N has 4s, 4p, 4d, 4f and so on. Dear students, 1s means this is subcell. Within subcell there are orbitals also. Remember, S has only 1 orbital, isn't it? This K cell has only 1 orbital and only 1 subcell, which can carry 2 electrons, which can hold 2 electrons. Similarly, in L there is 2s and 2p. 2s has only 1 orbital, 2p has 3 orbitals, which we have already discussed. So total orbital are 4. Similarly, here is D, look at here, P has 3 orbital and D has the 10 orbital, isn't it? So 10 orbital, that means, sorry, I काट्नु पर्छ. D has 5 orbital, 5 to the 10 electron, 5 multiplied 2 equal to 10 electrons. So D capacity is 10. So altogether, look at here, how many orbitals are here? K has only 1 orbital and hold 2 electron. L has total 4 orbitals that can carry 8 electrons. Similarly, KLM has, look at here, 9 orbitals, 9 into 2, 9 multiplied 2, 18 electrons. Similarly, N cell has 4s, 4p, 4d and 4f. And their orbital number are here 16 orbital. Look at here, 1 orbital, 3 orbital, 5 orbital and 7 orbitals. So there are altogether 16 orbitals. 16 multiplied to how many electrons? 32 electrons will be accommodated in the N cell, isn't it? So filling of electron can be represented by this Aufbau principle, Aufbau rule, which we have discussed in previous classes. And the order of filling electron is like this. The order of electronic configuration, subcell electronic configuration is 1s, first of all 1s, electron goes to 1s, then goes to 2s, 2p, 3s, 3p, 4s. After filling 4s, 3d. Remember here 3s and 3p are the important point because it follows 19 potassium and 20 calcium also, because after filling 3p6 electron we cannot go to 3d directly. So first we should fill to 4s. Yes, this is the order of filling electron which is represented by this chart. Dear students, now in the classification of elements, these elements are classified into metals, non-metals and metalloids in the modern periodic table. Do you know what are metals? I have some of the items. Look at here. Here is a stick. Which part is metal, which is non-metal? Can you identify? Sure, definitely. This part is metal and this part is non-metal. How did you identify metal and non-metal? Yes, there are certain characteristics of metal. Metal, we see here, it is shiny, has metallic luster, it is non-shiny or not shiny, not metallic property, isn't it? It is dull, looking dull. Yes, by this also we can identify metal. And look at here, you have a pen, isn't it? In this pen, which part is metal? Do you know? Yes, definitely. Here is nib, this nib is metallic and other part or this body part is non-metallic. Yes. Similarly, in our daily life we are using metals and non-metals, and some of the elements have the both characteristics of metal as well as non-metal, isn't it? Another main characteristics of metal, can you see, can you recall that? Yes, metal are good conductor of heat and electricity. So our cooking utensils are made up of metals, isn't it? Non-metal are bad conductor. Its example is electric switch, electric cable are insulated. How electric cable are insulated? Yes, insulated by plastic, isn't it? Plastic is non-metal, but inside the insulated coat there is metal, that is copper, aluminum are used as a electric cable. So let's see, a part of periodic table is presented here. Dear students, there are altogether how many groups in the periodic table? Yes, there are 18 groups, and these 18 groups are further subdivided into A and B subgroups, isn't it? And in these groups, they are classified into different areas. Look at here. These are the metals. Metals start from group 1 up to group 13. Look at here. This part are metal, isn't it? And similarly, there are non-metals also. These are non-metals. Look at here, 14, 15, 16, 17, up to 18 inert gases. These are also non-metals. And non-metals are represented by this color. Look at here, these are the non-metals. And one separate color is mentioned here for the group 7A or group 17 because their properties is quite different than other non-metal. These are also non-metal, and another non-metal group 18 has also different color. What is the purpose of that? Why it is distinguished through different color? Yes, I'll explain about that. And here is, look at it, group 1 has a particular color, that is metal, and group 2 or group IIA has also another particular color. And here, look at it, in the middle part, in the main block of the periodic table, the group B, look at it, 3B, 4B, 5B, 6B, 7B, and group 8, 1B and 2B. These are also the metal, but what type of metal are they? We have to discuss about their properties, about their characteristics. And dear students, there is a separate color, look at here, there is sky blue, there is bluish color. These are represented by metalloid. Where are metalloid located then? Yes, sure, metalloids are located between metals and non-metals. Metalloids are semi-metals. They are also called semi-metals. They are neither good conductor nor bad conductor. They are the semiconductor. They partly pass electricity, isn't it? Because metal are good conductor, non-metal are bad conductor, insulator, whereas metalloids are semiconductor. These characteristics we are going to discuss. Now, position of metallic element. Let's discuss just metallic elements in the modern periodic table. Where are the metallic elements located? Just remember, yes, in left hand side of the periodic table are metallic element, whereas right hand side there are non-metallic element. Let's check it. Yes, these are metallic element. Dear students, I have left here one blank space. What is there? What are there in the blank space? This is the position of non-metal. Non-metal and metalloids are there. These are the metals. Look at it. Then what is the name of this particular metallic group? Because they are separated by different color, isn't it? Distinguished. Now let's discuss about it. Yes, the first group is called alkali metal. Dear students, the first group is alkali metal. Remember, what is alkali metal? Their characteristics also we will discuss. And second group, do you know what is it called? Second group, group 2 or group IIA is represented by what? Yes, alkaline earth metals. They are called alkaline earth metals. Then let's read out the name of the alkali metal. Except hydrogen. Hydrogen is non-metal because of its valency 1 and 1 electron in the valence shell. It is placed in group 1 with the alkali metal, although it is not metal. Metal of group 1A are lithium, sodium, potassium, rubidium, cesium, francium, isn't it? From top to bottom in a group, their reactivity goes on increasing, which we will discuss in coming class. And second group is alkaline earth metals. Alkaline earth metals are, look at here, beryllium, magnesium, calcium, strontium, and so on. Similarly, look at here, another group is, look at here, what is this? Transition metal. Transition metal are located between the group IIA and group IIIA or group 2A and 3A, isn't it? This is group 3A or group 13. This is group 2A or group 2. Between group 2 and group 13, remember, there are transition metal which are represented by this yellow color. Look at it. Starting from scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, isn't it? Iron, cobalt, nickel, copper, zinc, you are familiar about these metals. Besides these, other many metals are there and their characteristics. Think what can be the characteristics of alkali metals, alkaline earth metals and transition metals. Yes, we will discuss about their characteristics also. And yes, at the last of this, in the end of this group, there is a Sn. Sn means tin. Tin is also metal. Stannum. Dear students, here is one atomic model. Do you identify? Yes. Which element is it? Is it metal or non-metal? Sure. Yes, it is metal because it is atomic number 12. Atomic number 12 means, where is atomic number 12? Here is magnesium metal, isn't it? Magnesium 2, 8 and 2. Last valence shell has 2 electron. It belongs to group 2. So, metals lie between 1A or group 1 and 3A or group 13. Group 1 to group 13, there are the metal in modern periodic table. This is the position of metal in modern periodic table. And what is the characteristics of metal? Yes, the first characteristic is metal are good conductor of heat and electricity. Yes, good example is electric cable, electric circuit. You have prepared electric circuit in science lab or by to prepare for science experiment also. What do you use for that? Yes, we use the electric cable, that is wire, copper wire. Copper is metal or non-metal? Metal. Yes, so metal are good conductor of heat and electricity. Our cooking utensils are made up of metal. Similarly, most metal possess high melting point and high boiling point, high density. But remember, there are exception case. These metal, transition metal have high melting point, high boiling point and high density. But this alkali metal and alkaline earth metal of group 1A and group 2A have the low melting point, low boiling point and low density also. That is the exception case, and they are chemically highly reactive metals. Similarly, metals are lustrous. Lustrous means shiny. This is metal. What do you see? This is shiny, isn't it? Lustrous. And are electropositive in nature. Metal are electropositive in nature. Suppose, look at here, sodium is a metal. Sodium, it is represented by Na. It gives electropositive or electronegative? Yes, sodium metal loses one electron, so it gives sodium plus charge, isn't it? Magnesium is metal. It is magnesium. Magnesium loses how many electron? 2 electron, because magnesium valence is 2. And magnesium gives magnesium plus ion, isn't it? So metal gives electropositive ion. Dear students, some properties of metallic element we are discussing in the modern periodic table. What is the properties we have just discussed? So now let's discuss about the alkali metals. Why are they called alkali metals? What are alkali metals? This group is alkali metal. Look at here. It is highlighted group. That means lithium, sodium, potassium, rubidium. Group 1A element or group 1 element whose valence shell contain 1s1 electronic configuration. Remember, suppose lithium, sodium, potassium, isn't it? 2, 1, 2, 8, 1, 2, 8, then 8 and 1. Let's check their electronic configuration. 1s2, 2s1, 1s2, 2s2, 2p6, 3s1, 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Look at here. Its electronic configuration represent ns1. ns1. That means n represents 1, 2 or 3, isn't it? So this is the subcell electronic configuration of alkali metal. Alkali metal. And why are they called alkali? Do you know that? Yes. Look at here. Sodium, when react with water, what happens? Yes, it gives NaOH plus H2. Look at it. Hydrogen gas is released. NaOH means sodium hydroxide. Similarly, K plus H2O, what happens? KOH plus H2. Look at it. These are alkali. Alkali means this is sodium hydroxide, this is potassium hydroxide. We can balance the equation. Look at it. Put here 2 and hydrogen 2 like this. Here, yes, here also like this, isn't it? Now 2 to the 4, hydrogen 4. Okay, this is alkali. So sodium, potassium, lithium directly react with water and they give alkali. Alkali, this is basic character, isn't it? Sodium hydroxide, potassium hydroxide, water soluble base are called alkali. That's why this group This metallic group are called alkali metals. They react directly, they react vigorously with water and give water soluble alkali. So its electronic configuration and their alkali metal characters and hydrogen is the main feature of alkali metal, which we have discussed. These are reactive metal, highly reactive metal, because they have valency 1. They lose how many electron? 1 electron. And they are soft metal and have less density, isn't it? Similarly, another group is alkaline earth metal. Alkaline earth metal, look at it, this highlighted group II or group 2. Group 2A elements, whose electronic configuration represents NS2. NS2. Look at here. Magnesium, atomic number 12. 2, 8, 2. This is cell electron configuration. Now subcell electron configuration is 1s2, 2s2, 2p6, 3s2. Remember, magnesium has 3s2. Similarly, 20 calcium has, yes, other same, here will be 4s2, isn't it? 4s2, that means 1s2, 2s2, 2p6, 3s2, 3p6 and 4s2. This means it represents 1s2. NS2 is the electronic configuration, subcell electronic configuration of alkaline earth metal, which belong to group II or group 2 in the modern periodic table, isn't it? And they are basic oxide. They give basic oxide. Suppose magnesium plus oxygen, what gives? Magnesium oxide. And this magnesium oxide, when dissolved with water, it gives magnesium hydroxide. Remember, magnesium plus oxygen, it gives magnesium oxide. Look at it. This is basic oxide. This is basic. And when this magnesium oxide again reacts with water, this gives magnesium hydroxide, MgOH whole 2. This is alkali, isn't it? It also produces alkali. It gives basic oxide and it gives alkali by the reaction with water. This is alkali. So that these are called alkaline earth metals. They are found on the earth's surface, isn't it? And they are also soft metals like this. Look at here, beryllium, magnesium, calcium, isn't it? Strontium, and so on. Similarly, another metallic group is transition metal. Transition metal, remember which group are transition metal? Group IIA or group 2 to group 3A or group 13. Look at here, group IIA or group 2 and group 13 or IIIA. Yes, between this group, it is the indicated by the yellow color. This yellow color group represents the transition metal, isn't it? Their electronic configuration is totally different than the other metals, isn't it? Look at here, iron. Iron is atomic number 26. Iron atomic number 26. In previous class also we have tried to make the electronic configuration KLMN. Now 1s2 subcell electron configuration I am going to present here. 1s2, 2s2, 2p6, 3s2, 3p6. There is 3d also. But above principle says that we cannot go 3d. Before going 3d, we have to fill the electron to 4s. 4s2. Now, how many electron we have filled here? Here 2 electron, here 8 electron we have filled, and here we have filled 8 electron, here 2 electron. That means 20 electron are gone. Now remaining 6 electron go to D. isn't it? So here will be 6 plus 6, 12, 12 plus 2, 14 and 2. Yes, until the 18 number we can fill here in the m orbit. So this is the electronic configuration of the iron. Now look at here, this is n minus, this d means third electronic configuration, third cell has the d. So its block is d and its electronic configuration is different than the other elements. So it is represented by, look at here, ns2, n minus 1, d, 1 up to 10, ns2, n minus 1, d, 1 up to 10. This is the basic electronic configuration of d block element. Look at it, ns2 means third s2, look at it, n minus 1 d, n minus 1 d, ns2 and np6 also, then n minus 1 d and 1 d1, 3d1, 3d2, 3d3 up to 3d10 we can fill their electronic configuration, which you will study in higher classes, higher level, not in class 10. Yes. Now look at here, the d block elements are the transition element. Dear students, now we are going to discuss about the non-metallic elements. Do you know non-metallic elements are different than the metallic elements which are bad conductor or insulator, isn't it? And they are soft, low density, isn't it? Not metallic luster, and they are different than the metals. So element belonging to, look at it, 4a, that is 14, to the group 7a, 17, and the group 0 or group 18 of the modern periodic table are non-metal. Look at it. Group, it begins from group 13 also. In group 13 some are soft metal. It begins from group 14. Look at it. Group 14 means 4a to group 18, group 0. Group 0 are the helium, neon, argon, krypton, xenon, radon. These are chemically inert elements. So elements are placed in right hand side of the modern periodic table. This is right hand side. In left hand side there are metals, right hand side there are non-metals, and they have electronic configuration ns2 np1 to ns2 np6. Look at it. This look at it, carbon has, look at it, yes, electronic configuration carbon to electronic configuration neon, argon, we get here np6, which electronic configuration you have already practiced in the previous class. Similarly, elements having outer orbit duplet or octet state are placed in the, yes, last group, that is the 0 group or group 18. They are chemically inert or non-reactive elements. What are they? Yes, here we have represented by the yellow group, yellow color, helium, neon, argon, krypton, xenon, radon. There are 6 elements which are chemically inert, inactive, whose valence is 0. Yes, so non-metal are usually non-conductor of heat and electricity. Then they are soft, having low melting point and low boiling point. They are non-lustrous and non-shiny. They are not shiny and are electronegative in nature, isn't it? We are using non-metal in our daily life. Yes, so many non-metals are here. Look at here. These are non-metal and no metallic luster, not shiny. They are not good conductor of heat and electricity. Dear students, now let's discuss about metalloid element. Yes, I have already told you metalloid elements are here between metals and non-metals. Here we have some of the elements metalloid elements, these are the elements which lie between the metal and non-metal and show the properties of partly metal and partly non-metal in between group 3A or 13 to group 6A or 16, isn't it? Their position is here in the periodic table. Yes, their electrical conductivity is weaker than the metals, isn't it? They are weaker electrical conductivity is stronger than non-metals. Their electricity, they conduct partly, so they are weaker electrical conductor and are also called semiconductors. Yes, semiconductors. Suppose silicon chips. An important element is silicon, where computer microchips, do you know? Yes, microchips have the silicon metals because it is semiconductor. It is metalloid element. Look at it. Boron, silicon, germanium, arsenic, antimony, tellurium, polonium are these metalloids or semi-metals whose characteristics lie between metal and non-metals. Dear students, we have discussed what are metals, what is their characteristics, what are non-metal, what is their characteristics, and some metalloids which lie between metal and non-metal. Let's perform one project activity. I am providing you one activity to you. Dear students, let's enjoy one project activity. Yes, this is for you. What is the project activity? Fill up the elements from atomic number 1 to 20 in the given piece of modern periodic table. Also highlight metals, non-metals and metalloids with distinct color in the box given. Now I am providing a box. Let's see. Yes, some of the elements are filled here. Look at here. Here hydrogen is filled, magnesium, calcium are filled. Remaining electron you have to fill here, isn't it? What are the elements there? Yes, there is boron, aluminum. After that, what will happen? And in group 4A, you have to fill totally. Group 5A, 6A, and 7A remaining, and 0 group. This element you have to fill. Dear students, now we are performing one activity. What activity? Yes, multiple choice question we have to practice. Choose the correct alternatives from the given. Now, let's see. The question number 1 is like this. Which of the following represent electronic configuration of the alkaline earth metal? Yes, look at here. 1s2, 2s2, 2p6, 3s2, 3p1. Try to find alkaline earth metal, isn't it? 1s2, 2s2, 2p6, 3s2, 3p2. Yes, remember what is the group of alkaline earth metal? Third one is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Is it correct? Or the last one is 1s2, 2s2, 2p6, 3s2. It is correct? Yes, definitely. You try to find. Let's check it. Sure. Yes, 1s2, 2s2, 2p6, 3s2. What is its atomic number? Yes, if you add and the electron, there is atomic number 12. 12 electrons are there. This is magnesium. Magnesium is the correct answer. Now, let's discuss question number 2. Question number 2 is like this. Which of the following is an example of metalloid element? Yes, we have discussed metal, non-metal and metalloid. Sulfur, silicon, potassium and argon. Did you know? Sure. Let's check it. Silicon is the metalloid element. Question number 3. Question number 3 is like this. Which element are placed in between group IIA to group IIIA? That means group 2A and 3A. That means group 2 and group 13 in modern periodic table. Which elements are placed? Transition metals, non-metals, metalloids or alkaline earth metal? Yes, definitely you have found the correct answer. Let's check it. transition metals are placed between metals, and that is group 2A and group 3A. Dear students, we have discussed about position of metal, metalloid and non-metal with their characteristics in modern periodic table. I think you enjoyed today's class, and its remaining part we will discuss in the coming class. Today's class is over. Thank you. Namaste.